Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 1589, maximum sum obtained of any permutation. So what you want to do is try to find a permutation of nums where if you add the sum of all these subarrays, they become the maximum. And you can reorder this in any way you want. So the brute force approach is pretty simple. Just for each permutation, try the entire request and find the biggest one. But that's obviously not going to be good enough if you look at the constraints. So let's try to make some observations here. Basically, you see that some subarrays are covered more than once, some positions. Like one here is covered more than once, right? So why don't we just go ahead and sort by how many times each index appears, right? And then because those are going to be prioritized by giving those indexes, aka 1, the biggest elements. And then the smaller elements to the ones that are less frequently appearing, like 0 or 3. Right? Because 0 and 3 only appear once. So if you think of this like a number line, so this appears once, and then this appears once. So 1 is shared, has the biggest frequency. So we want to give it the biggest number of 5, right? Cool. So let's go ahead and make a sorted list of nums. And let's first get how many times it appears. So let's call this frequency is 0 times length of nums. And then let's just go through, and for start and end in requests, basically we're going to say, we're going to accumulate, so we're going to add for each number in 1, 2, 3, we're going to say, okay, plus 1, right? So this is going to be going from 0, 0, 0, 0, 0 to 0, 1, 1, 1, 0 after we process this, and then after we process this, then we're going to have 1, 2, 1, 1, 0. So this is the order we want to sort by, right? Cool. So then we're going to also subtract this because we're just going to basically use a prefix sum technique. This is called the difference array technique to go. So if we want to add 1 or 2 to this segment, then first of all, add 1 to this segment, and then from this segment subtract so that when we accumulate, everything accumulated is going to be up to this bar only, so the exact subarray, right? Whatever that number might be, in this case, it's just 1, right? If you want to add 2 to it, then the same thing, and then by the end, if this is still in bounds, because this might be out of bounds, then we're going to say accumulate frequency, right, from left to right, keep accumulating, so 1, 3, 4, 5, 5, for example, if we're looking at it like that. But in this case, we only want to do it by 1, right? This is for 1, 2, and 3, only increase those positions by 1. Cool. So now we have this, and we want to sort by this. So let's make another array called current, and let's go through frequency. And basically, since this is the biggest frequency, right, we're going to give it, we're going to append this value and also the position, because the position is supposed to hold the biggest value, right? And then we're going to go ahead and sort by just this frequency. So let's print current, and we want this to be sorted in reverse order. So let's do this. So what this tells us is that index 1 should get the biggest value, and then index 0 should get the next biggest value, and then 2 should get the next biggest value, and then index 3, index 4, etc., right? So now that's where this sorted list comes in handy if we created it, because basically now we want to create a copy is going to be, let's say, -1 times length of num, so just filling a dummy value, and then basically for each value in current, so let's call this AB in current. Basically, we want this to have the biggest value. So we're going to insert at this index, right, at this index, the next biggest value we see, which is just going to be the rightmost element in the sorted list, right? Because the sorted list sorts from left to right, smallest to greatest. So that is going to make it so that we get what we want. Let's print copy. So what this tells us now is this is going to give us the most optimal path for these because we weighted them in terms of how frequently each index appears. So now we can go ahead and create a prefix sum of copy so that we can get each subarray sum. So 1 to 3 and then 0 to 1. Notice that is 19, right? We can check our work here and it's correct. So last but not least, let's include this mod. And let's go through requests once more. So for A, B, or start and end in requests. Again, the way prefix sums work, if you want the sum of this subarray, it's accumulate this minus accumulate that. If you're at the beginning, then it's just accumulate this position. So if S is less than or equal to 0, then the prefix sum is just P of E. Otherwise, the prefix sum is P of E minus P of S minus 1. Right? And then at the end, we can just add the prefix sum because we know it's going to give us the most optimal solution and return answer modulo mod at the end. Okay, let's run this. Comment these out and submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.